name is Trevor Arndt. This is my video lab report for the second lab. This is my introduction. The purpose of this lab was to calculate the strength of the magnetic field relative to its distance from the magnetic field. We observed this phenomena for both on and off axis observation locations. The physics principles in this lab were the magnetic fields, and we modeled these using the Biot-Savart law, which is pictured in the bottom right. The results for this lab, I found mu to be 2.81 and n to be negative 1.938. Procedure for this lab, we determined the direction of magnetic north, aligned the magnetometer with magnetic north to cancel out interference from the Earth's magnetic field, placed the magnet with its axis pointing along the Earth's east-west axis, and then recorded the distances between the magnet and the sensor for different Bx magnitudes, where the sensor was on axis and then also perpendicular to the axis. Here are a couple observations I made in my experiment. As the distance between the sensor and the magnet decreased, the magnitude of the magnetic field increased. And then outside a certain distance, the magnetic field in the x direction was recorded as approximately 0. A couple assumptions I made were that the magnetic field is dependent on a constant times the distance to some power, which is pictured in the top right. R is the only variable in this equation. All other terms are constant. And outside factors do not affect the magnetic field observed, such as the Earth's. And the system was the sensor. The magnetic field, or the magnet, caused an external magnetic field, which was observed by the system. On the left is the data that I recorded for I recorded the distances which gave different magnitudes of the magnetic field. And then using this data, the spreadsheet calculated or plotted that data and then created a line of best fit, which is, which you can see it's depicted by the line of best fit here. And to find this line of best fit, we use the formula ln of the magnetic field in the x direction is equal to ln of k, which is a constant, plus n times ln of r, which is the distance. The results from the experimental portion of the lab, I found the equation of the magnitude of the magnetic field dependent on distance was found to be the following. ln of b of x is equal to negative 1.938x minus 14, n equals negative 1.938, which was found from the slope. Mu is equal to 2.81, which I found by manipulating the y-intercept. The expected value of n was negative 3, which is very different from what I found, but there was possibly a lot of human error when recording the data, mislining the sensor with magnetic north, or because the type of magnet that I bought was different than the one provided. Here are my results from the coding portion. The teal arrows are the perpendicular magnetic field, the orange arrows are the on-axis magnetic field, and the magenta is the off-axis magnetic field. Here's a continuation of the coding part. I'm only going to focus on this formula which I created because all of the other parts were found using this formula. But basically this formula is the Biot-Savart law, which is pictured in the top left, where you are given a mu, which is the moment of the magnetic dipole, and r, which is a distance from the magnet. And then using that, you can plug it into the equation to find the strength of the magnetic field at that location. Here's a comparison of my data between the coding and experimental portions. The values were far different between these two, and this error is most likely due to human error when recording the data or aligning with north, or because the magnet I bought was different than the one provided and it had a different axis. Here are a couple of follow-up questions. So if we hadn't oriented our setup to compensate for magnetic north, we would probably have, we would definitely have to account for the magnetic field due to Earth when calculating our results. Otherwise, the magnetic field would heavily be influenced to point along Earth's magnetic field because it's a much larger, it causes a much larger magnetic force. And if we had used 2 identical magnets instead of 1, mu would be increased, which goes into factor in K, and the magnitude of the magnetic field in all positions would increase because the magnet would double in strength. And that concludes my lab report. Thank you.